Properties of logarithms. We're going to go ahead and get started today by copying down the three properties of logarithms. You'll also be copying these down in your foldable as well. The explanation or the description is not going to be on your foldable, but the algebra will be. So this is a little bit more thorough of a set of notes than the one you're going to receive on your foldable. So just keep that in mind. This does more explanation than what you will receive in class tomorrow. After you've completed the notes for this top portion, continue on with me down below. Okay, now we're going to use properties of logarithms to simplify logs. Express as a single logarithm means condense. We're going to condense these logs down. When condensing, you want to identify first that the bases are the same. This only works if the bases of each log are the same. So if you get a base 3 here and a base 4 there, these two logs can't condense, and therefore it is simplified. However, since this is the same base in both cases, we'll go ahead and simplify it. The second thing we do when we're simplifying or condensing is looking for the symbol. The symbol that happens between these two logarithms is a subtraction sign, so that's my quotient property, which means I'll be dividing 27 by 9. Looks like this. Log base 3 of 27 divided by 9. Log base 3 of 3. And I know from my properties that if the base of the log and the argument are the same, the answer is 1. That's the simplify if possible part. Alright, I know that there's a whole number being multiplied by the log. Therefore, when condensing, I'm going to replace that whole number back as an exponent with the argument. So this becomes log base 10. Remember, if it's not written, it's base 10 of 2 to the 5th power. 2 to the 5th power is 32, so it's log of 32. Next one, we're going to identify that the bases are the same. They are, therefore we can condense. We're going to identify that what symbol it is, therefore we can understand what property to use. The product property will be the one I use to condense this log. Log base 1/3 of 1/9 x. Next, we're going to look at these two, same base. Again, multiple properties going on here. The first property is the quotient property, and the second property is the exponent property. So I'm going to go ahead and write my logarithm, log base 5. I'm going to start with my first argument, 2, times my second argument, y squared. And so that is log base 5 of 2y squared. Again, multiple properties going on here, in fact all three. So there's my first one, my power property, my product property, and my quotient property. That means that r and s will be on top of the fraction and x will be on the bottom. Identify that your bases are all the same so that they can all condense into the same logarithm. They can. So I'll write the single log base b. I'll start with r to the 7th power, s divided by x. And there's my final answer. Okay, so now we're going to identify what's happening to each of the terms inside the argument. So notice that the exponents on each term in the argument are 1, therefore the product or the power property will not be used. There's no fraction, so we're only dealing with the product property. Remember, each term inside the argument gets its own log when you're expanding. So that's log base 10 of 7 plus log base 10 of x. Notice again that we've got 3 terms inside the argument. Notice here that you've got an exponent on the y term of the argument, and notice that we've got multiplication between the 3. When expanding, each term inside the argument gets its own logarithm. And now I'm going to continue with my whole number 2, because that's the number and that's the term of the argument that gets the exponent. And there's my condensed or expanded answer. Notice I've got 2 exponents here, so each of the logs are going to have a whole number multiplier in front of them. And I've got the quotient property, so I'll be using subtraction. Log base 7, and that'll be a 3 in front, of x minus 4 log base 7 of y. Questions 9 through 14 will be simplifying. So we are going to take a look at this by expanding it. So it's log base 4 of 4 plus log base 4 of x. Well, from properties of logarithms, log base 4 of 4 is 1. So that's going to be 1 plus log base 4 of x. Next thing we're going to do here is we're going to expand this. Log base 6 of 1 minus log base 6 of 36. So now my properties say that this is 0 and that is 2. So the answer to this question is negative 2. The way that I know this is 2, remember, is to write that small switch from log form to exponential form. 6 to the x power equals 36. The number x has to be 2, so that's how I know that that's the case. Log base 3 and the base of the exponent 3 cancel out. When they cancel each other out, what's left is the argument, so x equals y is your answer in that case. I'm going to go ahead and move this little guy first back into the exponent, so it looks like this. 2 to the log base 2 of 27. Now my logs cancel. My final answer is 27. So while things do look confusing, they're really not all that bad. Log, if it's not written, is base 10, so I'm going to go ahead and rewrite it. Log base 10 of 1,000 minus log base 10 of 10. Okay? There's 2 ways to deal with this problem. The first way is to simplify each one individually by switching it into exponential form. So 10 to the x power equals 1,000, and solve for x, minus 10 to the x power equals 10. So the x's are what I'm looking for here, and that's going to be 3 minus 1, which is 2. Now the other way to look at this, of course, is by condensing. So I'll come over here to the side and we'll condense instead. Log of 1,000 divided by 10. Well, the log of 1,000 is 100, so we write it as log, remember it's base 10, of 100. And now I can switch this to exponential form. 10 to the x power equals 100, and it'll still give me the same answer, x equals 2. Over here, we're going to use the power property to get these in to their exponents, and then we'll use the product property to condense them down. So I get log base 6 of 2 to the 3rd power, which is 8, times 3 to the 3rd power, which is 27. So now I'm going to do log base 6 of 8 times 27, which is 216. And now I'll go ahead and use that same exponential switch to determine if this is a simplifiable logarithm. So 6 to the x power equals 216, and that number has to be 3. Alright, we'll look at a little slightly different form of simplifying logarithms. When you're given these numbers, these actual numbers are the estimated answer of log base 10 of 2 and log base 10 of 3. Literally, if you put these in your calculator using the log button, you will get these numbers. Okay, so we are not making up any math here, we're just using these. This is more of an exercise in your ability to expand and or condense logarithms in the right way, because what we're actually looking for here is we're looking for a way to substitute this number 0.301 and this number 0.477, likewise 0 and 1, by simplifying these numbers using properties of logarithms. So what you want to do here is you want to look for a way to get 12 to turn into a combination of 2, 3, 1, and 10. So remember that 12 can turn into 3 and 4. Log base 10 of 3 times 4. Remember also that 4 can turn into 2 times 2. So I'm going to rewrite this as log base 10 of 3 times 2 times 2. Here are the terms of my argument. Here they are all being multiplied. So I'm going to rewrite this as log base 10 of 3 plus log base 10 of 2 plus log base 10 of 2. Now if you don't want to write this twice, obviously 4 is 2 squared, which would be 2 times log base 10 of 2. Now I'm going to use substitution property here, and I go ahead and get 0.301 plus 0.301 plus 0.477. When you calculate that result, that is your answer. Alright, on question number 16, we're going to take a look at this, and we're going to rewrite it as 7 log base 10 of 2. Pretty simple, we'll just do 7 times 0.301, and that is going to be your answer. Moving down to question number 17, we're going to look for a way to get 16 to turn into a combination of 3, 4, 1, and 0. So that's obviously going to be log base 10 of 2 to the 4th power. 4 times log base 10 of 2 can be substituted to 3.01 times 0.301, which gives you an answer approximately of 1.204. 9 turns into 3 and 3, so we're going to do log base 10 of 1 minus 2 log base 10 of 3. Log base 10 of 1 is 0, minus 2 times the log base 10 of 3, which is 0.477, and I get approximately negative 0.954. Last two problems. Question number 19, log base 10 of 30. 30 turns into 10 times 3, so log base 10 of 10 plus log base 10 of 3, and that's going to give me 1 plus 0.477477, and that's going to be my answer. Now in this problem, we're going to take a look at it from a slightly different point of view. This is 6 thousandths, so I'm going to return this to its fraction form, 6 over 1,000, And now I'm able to determine what this answer is. So that's going to be log base 10 of 2 times 3 divided by 10 to the third power. And there are my numbers that I can use. Log base 10 of 2 plus log base 10 of base 10, of 3 minus 3 times the log base 10 of 10. So that's going to be 0.477 plus 0.301, and this number here becomes 1. 1 times 3 is 3, and there is your answer. Properties of logarithms are pretty simple and pretty straightforward, but it's important that you're able to recognize how to solve them, how to manipulate the numbers, and that's what this activity was for.